Hi everybody, and welcome to another Scratch tutorial, this time focusing on an ACES workflow. Now, the good thing about this is that an ACES workflow in Scratch is no different from handling a Rec 709 or XYZ workflow. So, what will we be looking at in this tutorial? First of all, we will look at how to get footage into ACES color space. Next, we will set up the monitoring for ACES. And most importantly, take a look at how to work in ACES and how to set up your project correctly. Lastly, we'll have a look at how to render out ACES or from ACES to any other color space. Okay, here we are in our empty Scratch project, and let's start with loading a clip, for example a ProRes file from the Area Alexa camera. Load that here and enter into the player. Now, as you can see, this file looks rather flat because it is recorded in Ares log.c color space. Now, if we go to the matrix and to the config menu, we can see that this file is flagged as sRGB at the moment. Now, to get this file into ACES color space, we would need to load what's called an IDT, Input Device Transform. To load this file, go to the Load button here, and from the bookmarks, select ACES Transforms. Now, ACES Transforms are mostly written as a CTL file, short for Color Transform Language. So let's switch our file filter to CTL and go to IDTs and select Array. Now we're presented with a bunch of IDTs, each one for a different ISO value. In this case, I'm going to choose the one for an ISO of 800 and load that onto the file. As you can see now, the file looks pretty much crushed and somewhat strange, which is because Scratch doesn't yet know that the file now is actually in ACES color space. To tell Scratch, we can simply flag the file to ACES. And as you see, now the colors look correct. Basically, a CTL file can contain any transform. It doesn't automatically mean loading a CTL file means getting the shot into ACES color space. So this is why we need to tell Scratch manually. Now, Scratch also has live grading capabilities. If we enter the SDI Live View plugin from the construct, we will be thrown into the player, just like with any file-based clip. So let's start capturing our SDI stream. As you can see, this is a live stream encoded in the ACES proxy color space. If we go to the config tab, again we could load any transform that we want onto that live stream. Again, we'll be using our bookmarks tab to go to the ACES transforms folder, set our file type accordingly, and now load the CTL that transforms the live ACES proxy signal into ACES linear. And last but not least, let's flag the signal accordingly as ACES so Scratch knows how to treat it. As you can see, the procedure is basically the same as with a file-based clip, and as such you can work in ACES in an onset environment and create onset looks, save as CTLs, and use them in post again. Now back to our files. If we want to load IDTs to multiple files at once, we could go to the media browser, select all files here, go to the Grade tab, and load the CTL here, and also flag all the selected files here as ACES files after doing so. Now, this was for non-RAW files. For RAW files, there's a different workflow that actually is much easier. Let me add another construct and now load an array raw shot. Now, the good thing about RAW is that the image data in the file itself has not yet a color space attached to it. So if we enter into the player and now go to the shot menu, we can actually decide what should be coming out of this debugger. At the moment, it's set to log.c, so the resulting image out of the debugger will be a log.c image. If we switch that to ACES, Now the debayer will produce an ACES image and hand this over to Scratch. At the same time, if we go to the config menu, you can see that Scratch already flagged the shot correctly as ACES automatically. And that's why we can look at a pleasing image directly. The steps are similar for, let's say, red. In this case, red automatically is being flagged as Rec 709 because if we look at the shot menu, it is being debayered to Rec 709. So if we change that and debayer to ACES, you can see that Scratch automatically flagged the shot as ACES as well, and we will see a much more pleasing image. Lastly, let's have a look at Sony and load a file from the F65, just like so. And here again, automatically it's flagged as Rec 709 because that's the default for the file. But again, if we switch the debayer to ACES, we will be looking at an ACES image and it is already flagged correctly. So much for getting footage into ACES. Now let's have a look at how to set up our monitoring according to our ACES workflow. Therefore, enter into the player, right-click, go to Settings, and to the Monitor menu. Now in the Monitor menu, you can set up the output color spaces for both your interface monitor and your SDI display. Usually, when working in ACES color space, to monitor ACES correctly, you would need to load what's called an ODT, Output Device Transform, because a reference display or reference projector as such cannot display ACES as it is. So you need to bring in ACES into a different standard or color space in order to display it correctly. And this basically is being done through this drop down here. So you can see if I select, let's say Rec 709 in this case for this display, Scratch will now look at the source clip and see that it's an ACES, and so apply the correct ODT from ACES to Rec 709 to display the image on my interface monitor. Now on my SDI out, I actually have connected a P3 projector that of course expects P3 as its input. So for this, I set the drop down to P3, and now Scratch will again look at the clip and see that it's an ACES color space, and at the same time see that my SDI out needs to be P3. So only for the SDI out, Scratch will apply an ACES to P3 ODT. And this will ensure that I'm actually seeing the same image on my projector that I'm seeing on the interface monitor, given that both are calibrated for their respective color spaces. If I disable the Apply Color Space button here, you can see the ACES image as is, without the ODT transforming it into Rec 709. Doesn't look as pleasing. Now let's have a look at how to work with ACES in Scratch. First of all, let me exit the project and have a look at the project settings. First of all, I set my default format to OpenXR and ACES color space. So each time I'll create a new timeline, this timeline will be in ACES color space, and the rendering format of that timeline will be OpenXR 16-bit floating point. The next thing is, here I can select which ACES version I want to use in this project, version 0.7 or version 1.0. Also, I can enable log grading if I want to have a much more natural feel to my color wheels than if I would be grading in ACES linear. So I'll keep that enabled. Let me give you a quick idea on what ACES log means in Scratch. So if we look at this image and ACES log is activated, grading this image feels much more natural using the color wheels in Scratch, like you would be working on, let's say, a Rec 709 image. Now I can go to the setup and disable ACES log grading on a per shot basis, and if I do that, I need to tweak the gamma ring much more to get the same result. simply because ACES linear color space is a very wide gamut, and to have the desired effect, the actual value change is much bigger than if you first squeeze your image into a log range. Now, grading this way feels very unnatural to the colorist. So let me keep this enabled. More technically speaking, what this option does is move an ACES shot into ACES CC, which is ACES log. And on this log image, you will be doing your grading and applying the grading tools too. However, before displaying it again or transforming it to any other color space or when rendering out, Scratch will move it back into ACES linear. Lastly, let's have a look at some config files in Scratch that would be needed if you're planning to set up a customized ACES workflow. Therefore, go to your system disk, Library, Application Support, Assimilator, Defaults, ACES. And inside this folder you will find the transform files for ACES version 0.7 and for version 1.0, with the subfolders including the IDTs and ODTs that you can use. Now if you open this ACES CTL Mappings XML with a text editor, you can see that depending on whether you selected version 0.7 or version 1.0 as your project setting, a different set of CTLs will be used for all ACES transforms in Scratch. Now if you want to customize your workflow, and let's say you don't want to use the Rec 709 ODT with the D60 white point, you could simply look in the version 1.0 folder, in the ODT folder, Rec 709, and here you'll find a different Rec 709 ODT that doesn't have the D60 white point. So if you want to rather use this one, just copy and paste the file name of that ODT and place it here instead of the ODT that is already in the mappings file. Make sure to save that mappings file not in the defaults ACES folder here, but rather in your settings folder. So you will keep the default and all-time working original XML file always in the defaults folder. One last note on editing the XML file. Please make sure that you do not break the formatting of the XML, otherwise Scratch will no longer be able to apply its automatic color management for ACES. Finally, let's talk about rendering out of Scratch. Therefore, let's go to Outputs and select our main output node. The main output node basically is our timeline. And as you remembered, I set the project defaults to OpenXR and ACES. So my timeline automatically is an ACES timeline. Now if I keep OpenXR selected and process this output node, I would render OpenXR files in the ACES color space. Now what else I could do is select the main output node and add another image output node and a second one. Now the first image output node can be set to, let's say, Rec 709, and this will do the following. Scratch will look at the main output node, which is set to ACES, and then look at the derived output node, which is set to Rec 709 and also has the apply button active. And this will trigger Scratch applying the correct RRT and ODT to transform from ACES, which is our timeline format, to Rec 709. Kind of the same that we did before for the display. Now this time it's for rendering. At the same time, I can create another version of it and have that transform to P3 if I want that. Or add another image file output node and transform to XYZ. If I set this format to, let's say, JPEG 2000, I could render a DCI compliant JPEG 2000 image sequence from my ACES timeline converted into XYZ. And for my Rec 709 output, I could add, let's say, a ProRes export node, set that to Apple ProRes 4x4 XQ with 2 audio channels, and now export this ProRes file in Rec 709 color space by adding it to the process queue together with my P3 EXRs, my ACES EXRs, and also my XYZ JPEG 2000 export. If I now go to the process queue, I can just stop this queue and, while it runs in the background, continue working on other timelines. Alright, that concludes our ACES workflow tutorial. Hope it was useful to you and see you next time. Bye.